At eDataSource, we have developed several tools that make parsing receipts much easier, and I'd like to show some of them to you today. The three major tools that we have developed can be found in the following three files: the address parser, the document navigator, and the ParserUtil. The first one that I'll talk to you about is the address parser. Normally, if you parse a receipt, you'll come across an address where the string is like the example on the screen, with a name and an address that's new lines separated. If you want to parse the receipt, you typically have two options. The first one is to build it yourself using some sort of regex to find, for example, the city. You could take the first characters, or you could split it on the comma. The other option, which is the one that you should use, is to call AddressParser.parse on the string. The address parser is the result of several years of research in developing receipt parsers. It's very useful and will work in nearly every case. If you find yourself thinking to use regex to parse an address, you should probably be using the address parser. Other times, though, you'll find in an HTML document a case where the city and the state or some other address fields are very clear in the HTML. In those cases, it's okay to do it manually, to use CSS selectors or JSoup selectors to find the fields. But in general, you should be using the AddressParser.parse on the string. The other tool that we have developed is the DocumentNavigator. We've found over the years that certain ways that you would use JSoup are a little complicated, and so we made the DocumentNavigator as a sort of a thin wrapper to JSoup to make those things easier. You simply create it in any number of ways. You can pass in the HTML string, or in most parsers, since you'll have the JSoup element, you can pass in the JSoup element to the new document navigator. And you use it like this example here. This contains own is a JSoup CSS selector. You should become familiar with JSoup CSS selectors. The next sibling deep is basically a wrapper for JSoup's similar options. Probably the most useful way to think of the document navigator is as a pointer that points to different elements. For example, if you have this HTML field here, this document has a table and the row has a subtotal and the next row has the dollar amount. If you create a new document navigator, the pointer, or the navigator often called, starts at the HTML element. The first thing that you might run is probably contains own subtotal, which looks for any element that contains in itself the text subtotal. Please be sure to check out the JSoup specifications for the CSS selectors. They are incredibly helpful. When you run select first, it will find the first element that contains that text subtotal, and so it moves the pointer to the paragraph element, as you can see here. When you call next child deep, what it does is it moves the pointer up the HTML DOM tree until it can find the next child element. First, it would move it to that TD element, and then it would move it to the TR element, because in both of those, in the TD case, there is no next child. In the TR, there's the next child. And so at that point, it leaves the pointer at the TR element you can see on the screen. Finally, when you call text, it gives you the cleaned text. Typically on a JSoup object, if you call .text, you might not get very clean text out of it. You might get HTML encoded objects, but we've developed the Document Navigator to give you cleaned, sanitized text. So in this case, the text that comes out of it is 1753, as you can see here. One more useful thing that you'll find is that at some point you'll find yourself wanting to create a copy. And simply call .navigator on it, and it will give you a copy where the pointer is at the current element. So if you've called that next child deep, like here, then when you call .navigator, it will give you a Document Navigator object where the navigator location is at that TR element. The final tool that I want to talk to you about is the ParserUtil. The ParserUtil has been in development for several years. It is used by nearly every parser that we have and has a lot of active development behind it. It has many small tools built into it. You should spend some time reading through the code, and you should use it. It's very useful, and it's worth your time to spend a lot of time studying through it so that way you can make use of it. Please use it. If you find yourself doing anything that seems simple, you should look inside of the ParserUtil to see if there's a tool that already exists to do that. There are 5 general sets of tools available. All of these are accessible as methods on the ParserUtil class. They're static methods, so you can just call them directly by passing strings or elements or date objects into them. These are the 5 tools that are generally available, and I'll go into depth on more of these here. The first set of tools deals with dates, for making and parsing dates. And for those, there are 5 methods that are used most of the times: getDate or getSystemDate, and I'll talk about the difference between the two of those later. AddDays.toDate, also available AddMinutes.toDate, AddHoursToDate, AddMonths.toDate, AddYears.toDate, where you would pass a date and an integer object and it would add it to it. You can also get the number of days between the date using getDate diff in days. And then we also support date parsing using getDate. Please explore the getDate parsing where you pass in the string. It's very useful and is used in many places, and it will make parsing dates much easier. The first tool that I want to talk about is the getDate/getSystemDate. Later on you'll find that you can pass in a string and call on the method getDate, and it will get you a date object. What's complicated about this is that if the time zone is specified, then you may find issues where the parsed date may or may not include the time zone, and if you call ParserUtil.getDate, it gets that date in the UTC time zone. But if you call getSystemDate, it calls that date with the time zone of whatever the computer is that you're running at. This is a slightly complicated topic. I suggest that you copy this code or something like it into a computer editor, run the Java code here, and set your computer time zone to different time zones to see if you can find errors. Please play around with this until you feel comfortable with it. It will make testing much easier. Our test servers are typically UTC, so if you find this too complicated, just make sure to set your computer to UTC time, and everything should work fine. The other tool that we have is AddDays.toDate, which is also available as AddMinutes.toDate, AddHoursToDate, AddMonths.toDate, and AddYears.toDate. For example, you might find in your HTML the text "will arrive in 3 days," and you want to find a date that you would call the delivery date. If you get the sent date of the email and add 3 days to it, then you have the date that the package is expected to arrive. Simply call add days to date, passing in the date of the email and the days parsed out of the email, and you'll have a date that's 3 days in the future. Another tool that may be less used is getDateDiff in days, where if you have 2 dates, it will calculate the days between them. This is not so common in e-commerce receipts. It's typically used in travel receipts. Another date utility is the getDate, where you pass in a string. Over the several years that we've been doing e-commerce receipts, we've developed a pretty solid date parsing mechanism where if you pass in a string to the getDate method, it should give you back a good, accurate date. However, at times you'll find really strange date formats in receipts. For example, this one here. The format is a simple date format object syntax. Please check that out online. The documentation is very helpful. Here we see the format specifies year, hour, minute, AM, PM, month, and day. Calling getDate with the format and the date string will get you back that date. Again, check the documentation for the simple date format syntax, and also check out the getDate method in the ParserUtil for more information and more examples. A lot of what you'll be working with is HTML and text, and we've developed several methods that are useful to get out and clean the text that you find in the HTML. For example, if you're given some HTML here where the and NBSP semicolon, which is the HTML encoded space character, if you call the text from that, you'll have the characters and NBSP semicolon. But if you call get text from HTML, it will convert that to a space. Many characters are already supported in the get text from HTML method, but if you do find yourself wanting additional characters, then please contact one of the developers and we'll add it in. Another option that you'll find is that HTML that's separated, for example with line breaks, as this example is here, or paragraphs, or ordered lists. If you pass in that HTML to get lines from HTML, you'll get a string array which contains the text of those different lines. This can be very helpful for parsing things such as addresses or multi-line descriptions and that sort of thing. If you're working with regex, there's one particular pattern that I'd like you to follow, and that is to put your pattern object with pattern.compile, passing the regex string into it, at the top of the class as a private static final. This will make the regex compile once for the class across the parsing utility. I'll show you an example here. Inside of an older parser, you can see the class at the head has the pattern here, and then that's used later down in here in a private method, parse order number. To use regex, we've developed two useful tools, that is get optional and get required. In this example here, you can see a familiar thing where you have an item description and an item quantity inside of the parentheses. I've developed a simple regex here. There may be better options for the regex. What I would like to show you though is that this has two groupings. Now, when you take the pattern and you compile it, then you call the matcher on it and pass in the text, you can call ParserUtil.getRequired, passing in the matcher, the group number, and a description of the group. For example, in this one, I'm saying that the description is the text description, and in the getOptional you can see the description is the word quantity. This is used for the logging. If you call getRequired and that text is not found, it will throw an exception and it will stop parsing the receipt. This is preferred to inserting bad data into the database. So if you find that the description, for example, is always present and is required, you should be calling ParserUtil.getRequired. On the other hand, you might find in some cases that a quantity is sometimes available and sometimes not available. In those cases, you would call getOptional, passing in the matcher, the index of the group number, and a description, and then you can pass in a default value. So for example here, if there's no quantity available in the text, I'm setting the default quantity to 1. One thing that you'll find is that in HTML, a space character is not necessarily a space character. What I mean is that the HTML has encoded space characters, in this case, a non-breaking space character. Of course, if you call the typical string trim on that string, it will still be including the non-breaking space encoded. But if you call the ParserUtil trim space characters, it will trim the non-breaking space. However, even stranger is that you'll have text that in your debugger will look like it's a normal space, and if you call trim on that, the space will stick around. But if you call trim space characters, the space will be removed. That's because not all spaces are spaces. The normal space character has /s and regex, but there are several different space characters available to Java. If you use the ParserUtil trim space characters, then those other types of space characters are taken care of for you. Another big thing that you'll be doing in receipt parsing is using math. Specifically, getting dollar amounts from receipts. We've developed a lot of different tools to handle currency and to handle math easier in Java. One of those is the ParserUtil method $to_double. In this example here, you can see there are spaces and commas and a dollar symbol. And if you call double.valueOf, of course this will throw an exception. But if you call $to_double on the ParserUtil and pass in the text, what comes out is that double value as you would hope. This is very easy. You should use this. Be sure to check out the ParserUtil for other methods that are helpful for handling double arithmetic. I'll get into some of those later. Getting integers from string is slightly easier than using integer.valueOf, but still expects a cleaned string. So here I have the string as the raw integer values, but if I had included a decimal or a space character, this wouldn't work. The main benefit of calling ParserUtil.getInteger is that you don't have to include the try-catch. If the string can't be parsed as an integer, it will throw a parser exception that's easier for our system to log and take care of. You should use the getInteger anytime that you're turning text into integer values. If you're familiar with Java, you'll have found that using doubles in Java leads to rounding errors. This is solved by using big decimal. In eDataSource, we've developed some standardized ways to handle doing double arithmetic. Inside of the ParserUtil, you'll find methods that are called add, subtract, multiply, and divide. Please explore these to be sure that you're comfortable doing double arithmetic with our tools. In this example, the two values, if they're divided, will often give you a rounding error. But if you call ParserUtil.divide with those two values, the rounding error isn't present. Some of the methods support passing in several values. For example, the add can pass in any number of values and it will give you the sum of those values. Another thing that you'll be wanting to do is validating some receipt totals. Most of our receipts, in fact, pretty nearly all of our receipts, should always balance. So if you get a receipt object and you're finished parsing it, you should be able to call ParserUtil.receiptTotalsBalance and pass in the receipt object, and you'll get back a Boolean which is true if the receipt totals balance. You can use this sometimes for complicated receipts to figure out ways to balance dollar values. But typically, at the end of the parser, what you'll call instead is, on the validate class, receipt balances, and pass in the receipt object. What this does is it uses our standard dollar balancing algorithm to balance the credits and the debits of the receipt, and then it will throw a validation exception if they don't balance. Typically, it's preferable to throw a validation exception for unbalanced receipts instead of putting unbalanced receipts into the database. Having bad data in the database is very difficult. It causes a lot of problems with our customers, and we would prefer that a validation exception would be thrown instead. Inside of the ParserUtil, you'll find several other tools. Some of them are rather abstracted. The first non-null, you can pass in any number of objects, and it will just return the first one that's not null. The pick first from map, you can pass in a map, and you can pass in a list of strings, and it will look in the hash map for the first one of those lists that returns a non-null object. Filter map to list is similar in that you pass it a map, and that is a string key object value store, and it will, instead of giving you the first result, it will give you all of the possible results. Please check those out for more information. In receipts, we don't normally come across JSON, but in the past we have found receipts that also include the receipt data as a JSON object. If you find those, you can make a class that would represent the JSON object and call parse.json. It's very uncommon, so I don't expect you to come across it, but you might want to check it out in case you do. Be sure to check out the ParserUtil class, the AddressParser class, and the DocumentNavigator class, and become familiar with them. You'll use them every time that you create a receipt parser. And also be sure to check out the simple date format and the JSoup CSS selectors to become familiar with those. Thanks for listening, and welcome to the team. Be sure to ask if you have questions. We would love to make our tool better, so if you find ways to improve the code, be sure to suggest them. Thanks again.